So the next topic is solubility product. It's the product of the concentrations of each ion in a saturated solution of a sparingly soluble salt in standard condition. Sparingly soluble means that it's partially soluble and not fully soluble. So for example, let's say that this is a solution in which there is, let's say, AgCl dissolved and it's fully saturated. Means the maximum amount of AgCl that could be dissolved has been dissolved. So if we add more AgCl to it, then the AgCl cannot get dissolved. However, an equilibrium will be set up in which ions from AgCl aqueous will become solid, and AgCl solid will become aqueous. However, there won't be any net change. So this equilibrium will be set up, right? So the concentration of AgCl remains constant because there isn't any net. Sorry, this is an equilibrium. There isn't any net change, right? So now let's come to our example. This is a general case. So there is a salt CaAb which is partially soluble, and the equilibrium is set up this way. So the value of Kc will be the concentration of products upon the concentration of reactants. Now again, this is the solid, and since there is no net change over here, so the concentration of the solid is constant. So we can remove that, and then that is how we get the value of Ksp, which is the solubility product. That is the concentration of the product of the concentration of the two products, and the unit of this depends on the equation. For example, in this case, Ksp would be Ag plus concentration into Cl negative concentration. So the units would be mole per dm cube times mole per dm cube. So the units would be mole square dm power 6. So it depends on the equation, the number of moles of the ions. So now basically, if the product of the concentration of the ions is lower, that means that very few of the solid molecules formed ions. So that means that the salt was less soluble. So if the value of Ksp is high, that means more products were formed. So higher the value of Ksp, the more soluble salt. The lower the value of Ksp, the less soluble salt, and again vice versa, right? Ksp can be used to used to predict whether precipitation will occur when two solutions are mixed. Let's say there is barium chloride and sodium carbonate. So in this reaction, barium carbonate and sodium chloride is formed. Sodium chloride we know is soluble, so we won't consider that. Now in barium carbonate is insoluble. So however, even insoluble salts do dissolve very slightly, to a very less extent, which is nearly negligible. So barium carbonate dissociates into barium ions and carbonate ions, right? Now the Ksp for this is calculated at standard conditions as 5.5 times 10 power negative 10. So let's say if in a solution the product of Ba2 plus and CO3 negative is greater than the solubility product, in that case a precipitate will form. And if in the given solution the product of Ba2 plus and CO3 negative is less than 5.5 times 10 power negative 10, that is the solubility product, then no precipitate will form. The reason for that is that basically the Ksp value was the product of the concentration of the products, right? So if at the Ksp value there was equilibrium, however, if the value of the product of these two increases, is more than the Ksp value, then equilibrium will shift towards the left hand side, right? Which is why a precipitate will be formed. So when the product is more than the Ksp value, then a precipitate forms. However, if the product is less than the Ksp value, then equilibrium shifts towards the right hand side, and the solid dissolves completely. So there is no precipitate. I hope that's clear. Now let's take an example of calcium ion. So basically, calcium hydroxide is a partially soluble salt, right? And it dissociates into calcium ion and hydroxide ions. Now we have to find whether it will dissolve in NaOH or in NH3 aqueous, right? So NaOH is a strong alkali, so it fully dissociates into hydroxide ions and sodium ions, whereas ammonia is only partially dissociates into ammonium ion and hydroxide ion. So that's why the concentration of hydroxide ions in NaOH is high, whereas in NH3 is low. So since the hydroxide ion concentration is high, so the formula for Ksp is calcium hydroxide is calcium 2 plus times hydroxide concentration squared, because there is 2 moles, right? So over here, since the hydroxide ion concentration is high, so the product will be greater than the Ksp, which is why no precipitate will form, because as we read on the last page, if the value is greater than the Ksp, then the precipitate forms because the equilibrium shifts towards the left hand side. So if it's greater, then precipitate forms because the equilibrium shifts towards the left hand side. However, in the case of ammonia, the concentration of OH negative is low, which is why the product of the concentration of calcium ions and the concentration of hydroxide ions squared is less than the value of the solubility product, which is why no precipitate forms as the equilibrium shifts towards the right hand side. I hope this is clear. Is the common ion effect. So the common ion effect is basically the reduction in the solubility of a dissolved salt by adding a common ion. So what happens is that, for example, if there is a saturated solution of AgCl, right? So AgCl dissociates into Ag plus ion and Cl negative ion. Now, if another salt with the chloride ion, for example NaCl, is added, so what happens is that NaCl also dissociates, and NaCl is a strong electrolyte. It dissociates irreversibly into Na plus plus Cl negative. So the concentration of Cl negative ions increases and equilibrium shifts towards the left hand side, right? So AgCl solid is formed, which is why precipitation occurs. One more way of thinking of this is that as the chloride ion concentration increases, so the product of the Ksp, Ksp is basically Ag plus concentration into Cl negative concentration, and this product increases above the Ksp value, above the standard Ksp value, which is why equilibrium shifts to the left hand side and precipitate is formed. So the common ion effect basically reduces the solubility of a dissolved salt by adding a common ion. So the first question is the solubility of PbI2 is 0.46 gram per dm cube. Solubility is basically the mass or the number of moles of the compound that dissolves in a given volume. So 0.46 gram of PbI2 will dissolve in 1 dm cube. So it's basically, in other words, the concentration of PbI2 that can dissolve in the solution, right? So this concentration of PbI2 is in gram per dm cube. So to convert grams to mole, we have to divide grams by the mR. So 0.45 upon 461, 0.46 upon 461. This gives 9.98 times 10 power negative 4 mole per dm cube. Now we know that the equation of PbI2 is Pb2 plus 2I negative. So if the moles of PbI2, if the concentration of PbI2 is this, then the concentration of Pb2 plus that we had to find will also be the same, whereas the concentration of I negative, that is in the second part, will be twice of that because the molar ratio is 1:2. So I negative concentration is 9.98 times 10 power negative 4 times 2. That is 1.2 times 10 power negative 3. 1.2 times 10 power negative 3 mole per dm cube. And then lastly they're saying find the Ksp for PbI2. So Ksp will be Pb2 plus concentration into I negative concentration, and because there's 2 moles it will be squared. So it's basically 9.98 times 10 power negative 4 times 1.2 times 10 power negative 3 squared. It's 1.44. It's 1.44 times, sorry, this is not 1.2, this is basically for the ion negative concentration. It's basically 9.98 times 10 power negative 4 times 2. That is 1.99, approximately 2 times 10 power negative 3. So it's 2 times 10 power negative 3. Now for the Ksp value, it's 9.98 times 10 power negative 4 times 2 times 10 power negative 3, which is squared. It's 3.99, nearly 4 times 10 power negative 9. And the units will be, so this is mole per dm cube and this is mole per dm cube squared. So this will be mole cube dm upon dm power 9. I hope it's clear. Solubility product of silver phosphate is given. Use this to calculate the concentration of Ag plus. Okay, so basically we have silver phosphate, that is Ag3PO4. This dissociates into Ag plus PO4 negative. So the molar ratio is 1:3:1. So let's say if the concentration of Ag3PO4 was X, the concentration of Ag plus would be 3x and PO4 negative would be X, right? So Ksp value is basically the product of Ag positive whole cubed times PO4 negative concentration. So the value is 1.25 times 10 power negative 2 is equals to 3x whole cube times x. This is 1.25 times 10 power negative 2 is equals to 3 cube will be 27x power 4. So this is going to be 1.25 times 10 power negative 2 upon 27, and then this is coming equals to 0.1466. Right. The concentration of Ag plus, it is 3x, so we'll multiply 0.1467 by 3, 0.4401 mole per dm cube. Question: the solubility of Ag2S is 1.16 times 10 power negative 16 mole per dm cube. Calculate Ksp for Ag2S. So Ag2S dissociates into Ag plus S2 negative. So the solubility is basically equal to the concentration. So 1.16 times 10 power negative 16. This will be twice of that. 2.32 times 10 power negative 16, and this will be 1.16 times 10 power negative 16. So we have the concentration of the products. So Ksp will be Ag plus concentration squared and then S2 negative concentration. So that is 2.32 times 10 power negative 16 squared and 1.16 times 10 power negative 16. So Ksp is equals to 6.24 times 10 power negative 48, and the units will be, I hope you guys can do it yourself now, the units will be mole cube upon dm power 9. Then the second part is saying calculate the minimum volume of water needed to dissolve 1 gram of Ag2S under standard conditions. So it's 1 gram of Ag2S. So first you'll have to find the moles of Ag2S. That will be 1 gram upon the MR. MR will be 248. So the moles are coming as 4.03 times 10 power negative 3 moles. Right. Now, as I mentioned earlier, solubility means the number of moles that will dissolve in 1 dm cube of water. So 1 dm cube of water dissolves 1.16 times 10 power negative 16 moles. Now we have 4.03 times 10 power negative 3 moles. So x dm cube will dissolve that. So through cross multiplication, x is equals to 4.03 times 10 power negative 3 upon 1.16 times 10 power negative 16. 4.03 times 10 power negative 3 upon 1.16 times 10 power negative 16. Sorry, 4.03 times 10 power negative 3 on 1.16 times 10 power negative 16. 3.5 times 10 power 13 dm cube. Now the last question, 18.2 cm cube of 0.1 mole per dm cube of HCl reacts with 25 cm cube of CaOH2 for complete neutralization. Calculate the concentration of OH negative. Okay, so first let's find the moles of HCl. 18.2 times 0.1 upon 1000. 1.82 times 10 power negative 3. Right. So this reacts with calcium hydroxide, that is 25 cm cube. So calcium hydroxide reacted with HCl to produce calcium chloride plus water. Balancing this, so this will be 2 and this will be 2, yeah, 4 hydrogen. Yeah. So the ratio is 1:2. So if there were 1.82 times 10 power negative 3 moles of HCl, so there will be half of those. So x will be 1.82 divided by 2. So 1.82 divided by 2 is 9.1 times 10 power negative 4 moles of CaOH2. Right. So I basically have to find the concentration of OH negative ions. So if I find the number of the concentration of CaOH2 first, so I can use that to find the concentration of OH negative ions. So the moles of CaOH2 are this. Concentration, volume is 25 upon 1000. This will give the concentration as 9.1 times 10 power negative 4 upon 25. 0.0364. Right. Now in one molecule of CaOH2 there are 2 hydroxide ions, so the concentration of hydroxide ions will be double of this. So OH negative concentration will be twice of this, 0.064 times 2, that is 0.0728. Is the pH of the solution. So we have the concentration of hydroxide ions. So using the Kw expression, Kw is equals to H plus concentration, OH negative concentration. Kw is 1 times 10 power negative 14 is equals to H plus concentration, and OH negative concentration is 0.0728. So this is 10 power negative 14 upon 0.0728. That's 1.4 times 1.37 times 10 power negative 13. So pH will be negative log of this value. So negative log of the answer 12.9. This was the second part. In the third part, they're asking for the Ksp of CaOH2. So Ksp of CaOH2 will basically be Ca2 plus concentration into OH negative concentration squared, right? Ca2 plus concentration will be same as the concentration of CaOH2, that is 0.0364. So 0.0364, and then OH negative concentration we found as 0.0728 squared. So this will be 1.99 times 10 power negative 4, and the units will be mole cubed upon dm power 9. I hope this is clear. Topic is of partition coefficients. The partition coefficient is basically the ratio of the concentration of solute in two different immiscible solvents in contact with each other when equilibrium has been established. So basically it's that there are two different solvents which are both immiscible, which means that they can't dissolve into each other, and a solute is dissolved in both of them, and it's the ratio of the concentration of the solute in each of them. So let's say that there's an organic solvent and an aqueous solvent, and ammonia has been dissolved in both of them. So the concentration of ammonia in the organic solvent upon the concentration of ammonia in the aqueous solvent, which is aqueous is basically water. So this is the value of the partition coefficient, which is represented by Kpc. Now in this case, basically ammonia is soluble, is polar molecule. It has hydrogen bonding, so it's more soluble in water. So that's why the value of NH3, the denominator will be greater, whereas the numerator will be smaller. So that's why the value of Kpc will be less than 1 in this case. Now a general formula for Kpc will be the solute, the concentration of solute in this first solvent, which is organic, upon the concentration of solute in the second solvent, which is aqueous, and X should be in the same physical state in both the solvents, right? That's the basic formula for Kpc. Now there is one experiment that we can do to demonstrate the partition coefficient. So to find the partition coefficient, so basically the experiment is with hexane and iodine. So we'll take a separating funnel. There's a separating funnel, and we've added, there's water, there are two solvents, there's water and there's hexane. Now add iodine over here, right? And we shake the separating funnel, we mix it so that iodine gets dissolved in both the layers, and then leave it to stand for some time so that the layers separate, right? Once the layers have separated, so we collect both the layers in separate conical flasks or beaker, conical flasks basically, and then we titrate them with sodium thiosulfate. Now using this we can determine the concentration of iodine in both the layers, right? So once we have the concentration of iodine in both the layers, so then we can use the formula for Kpc, that is iodine concentration in the hexane layer upon which is the organic layer upon the iodine concentration in the aqueous layer to find the value of Kpc. So that's the simple experiment, and basically iodine is non-polar, so it dissolves more in the hexane layer, which is why the value of Kpc for this will be greater than 1. The question for partition coefficient: 2 gram of organic dye X is dissolved in 20 cm cube of hexane and 100 cm cube of water. It was found that 1.6 gram of X has been extracted into the hexane. Calculate Kpc of X in hexane and water and find percentage extraction in hexane. Okay, so basically there was 2 gram of X, 1.6 gram was dissolved in hexane, and the rest of the 0.4 gram in water. And the concentration of the volume of water was 100 cm cube, the volume of hexane was 20 cm cube. So we have to find the Ksp value. Ksp is equals to concentration of X in hexane upon the concentration of X in water. So I'll find the concentration of X in hexane. Concentration, basically moles is equals to concentration into volume upon 1000. So concentration is equals to moles into 1000 upon volume. Right, so basically we'll have, so for concentration of hexane is basically C6H14, right? So to find the moles, we'll have 1.6 upon the mr. So mr will be 6 into 12 plus 14, that is 86, into, sorry, this is 1000 upon the volume, that is 20, whereas for water it will be 0.4, sorry, I made a mistake. Basically the number of moles have to be of X, right? The number of moles have to be of X, so we need to find the moles of X. So 1.6 upon the mr of X, let's say the mr of X is let's say m, and over here again mr of X is m into 1000 upon 100, right? So this is the concentration in hexane, this is the concentration in water. So Ksp is equals to 1.6 times 1000 upon 20 m upon 0.4 times 1000 upon 100 m. 1000 cancelled, so it's 1.6 upon 20 upon 0.4 upon 100. So the Ksp value is equals to 20, and there are no units because the units of concentration of X in hexane were mole per dm cube and in water were mole per dm cube, so the units get cancelled, so there's no units. The value is 20. I'll repeat this once again. So there was 2 gram of X, 1.6 gram was extracted into hexane, so the rest of it was in water. This is the volume of hexane, volume of water. Now we have to find the concentration of hexane in concentration of X in hexane and the concentration of X in water. So the formula for concentration is moles into 1000 upon volume. So to find the moles of X, we'll divide 1.6 by the mr of X, let's say it's m, into 1000 upon the volume, that is 20. For water, moles is gram mass, that is 0.4 upon the mr, that is m into 1000 upon 100. So then we find the ratio, which is coming equal to 20. Then they're saying, and find the percentage extraction in hexane. So 1.6 gram got extracted into hexane from a total of 2.0 gram. So this is 80%. So that means that 80% of the hexane got extracted into, of the dye X got extracted into hexane. So next is the successive extraction method. In the previous question, only 80% of the dye got extracted into hexane. So how can we, in the same scenario, how can we increase the percentage extraction in hexane? Okay, so for that what we do is we use the successive extraction method. It's the same 2 gram of the dye X. Now what we do is that we take 10 centimeter cube of hexane, extract that, and then use the next 10 centimeter cube of hexane. So let's say that from the 2 gram of X grams of X in 10 cm cube of hexane, and 2.0 minus X gram of X in 100 cm cube of water, as it was in the previous question, right? Over here. This was 100 cm cube of water. So concentration will be x upon m into 1000 upon 10, and here the concentration will be 2 minus x upon m times 1000 upon 100. So I cancel these out. So we're getting concentration as 100x upon m and 20 minus 10x upon m. So the value for the value for KPC that we found, which is a constant, the partition coefficient, was 20, which is equal to the concentration of x in the organic layer, that is 100x upon m upon 20 minus 10x upon m. So m get cancelled. So it's basically 400 minus 200x equals to 100x, x equals to 1.33 grams, and 2 minus x is equals to 0.67 grams. So 1.33 grams got extracted into the hexane, right? Sorry. So 1.33 gram got extracted, and in the water 0.67 grams remained. So then we go towards the second extraction. So now what we do is that we mix this is 0.67 gram of x in water. So we mix water, which is 100 cm cube. So we mix this water with the remaining 10 centimeter cube of hexane. So this is the organic layer, this is the aqueous layer. So over here there's again, now let's say there's y gram of x in 10 cm cube, and here it's now 0.67 minus y gram of x in 100 cm cube. So to find the concentration, it will be y upon m times 1000 upon 10. Here it will be 0.67 minus y upon m times 1000 upon 100, right? So yeah, so it's basically 100 y upon m, and here it is 0.67 minus y times 10 upon m. So again, KPC, that is 20, is equals to 100 y upon m upon 0.67 minus y times 10 upon m. M get cancelled, 10 and 10 is cancelled. Now shift this over here. So it's 20 times 0.67, 13.4 minus 20y is equals to 10y. So it's 30y and then 13.4 divided by 30. So y is 0.44. So 0.67 minus y is equals to 0.67 minus 0.44 is 0.23, sorry. So this was an hexane. So in hexane, first we got 1.33 grams, then we got 0.44 more. So in two successive extractions, the total volume of x in hexane that we got was 1.33 plus 0.44, that is 1.77 grams. So to find the percentage extraction, it's 1.77 upon 2.0 times 100. This is equals to 88.5%. So earlier we only had 80% extraction. Using successive extraction method, we got 88.5%. So this increased the percentage. Go over this again. So what we do in successive extraction method is that first we use half of, if it's a two-step extraction, two successive extractions, then we use half of the organic layer half volume of the organic solvent and extract the dye into it first. So we use 10 centimeter cube and full volume of the water. 1.33 gram of hexane got extracted into the 10 centimeter cube of hexane, and 0.67 grams of X remained in water. So now in that 100 centimeter cube of water which had 0.67 grams, in that we added the remaining 10 centimeter cube of hexane. So we again performed extraction, and through this we got 0.44 grams of hexane which was extracted into the 10 centimeter cube of hexane. So sorry, 0.44 gram of X that was extracted into the 10 centimeter cube of hexane, and 0.23 grams of X remained in the water, right? So the total amount of X that was extracted into hexane was 1.33 plus 0.44. 1.33 in the first step and 0.44 in the second step. So that's the total mass of X extracted. So to find the percentage extraction, 1.77 upon the total mass, that is 2 into 100, it's 88.5. If we used like three times extraction, so we'd be using 20 divided by 3, 6.67 centimeter cube of hexane in every step, and that would further increase the percentage extraction. Then 4 times we would be using 20 upon 4, that would again further increase the percentage extraction.